Hello and welcome to video lesson topic 11.3. Tomorrow's will be 11.5. 11.3 is surface area of pyramids and cones. Today's learning objective is I am learning to find the surface area, which we'll abbreviate, of pyramids and cones. Now you're probably all familiar with what a pyramid and a cone is. If you're not, pyramids, you can imagine the pyramids in Egypt, even though all pyramids don't look like that. And then cones, you can imagine like an ice cream cone that comes down to a point, not the ones that are flat on the bottom. A pyramid, if we want to get technical, a pyramid is a polyhedron, so it is three-dimensional, where one face, this is called the base, it's going to be our bottom, is any polygon, and the other faces are triangles. So for instance, let's say that we had a square or a rectangle for our base, and then they all come and meet at this point. This would be like a pyramid you would see in Egypt. But it could be something else. Like today we're going to do some examples that are maybe a hexagon for the base, or a triangle for the base. The vertex is the point at which they meet. So that is called your vertex. A regular pyramid means the base is a regular polygon, and if you don't remember what that means, it's basically all the sides are equal, all the angles are equal. So an isosceles, or not isosceles, but an equilateral triangle, equal angular triangle, a square, a pentagon with all the sides equal and all the angles equal, and so on. Slant height, this is kind of odd. Slant height in a picture would look like this. So you got your pyramid, right? And they're all meeting right here. Slant height is literally this slanted height that goes from the base along one of the triangles to the vertex. The abbreviation that we use for it is a cursive L. And then the lateral area for a regular pyramid is your perimeter of your base times your slant height, and then should be times 1/2 out front here. I forgot to put that. 1/2 times perimeter, P is still perimeter, times L, which is your slant height. What that would be is the triangles along the outside. That would be the area of those triangles added together. And then your surface area would be if you added on the base's area. So that would be 1/2 PL plus the area of the base. B equals area of base. And since it's a pyramid, there's only one base. Now we're not going to do volume yet because volume is 11.5, which will be our last iLearn. We will, however, do a cone, and a cone is just like a pyramid except the base is a circle. We've all seen a cone before. The slant height, which we'll be using in a cone, is still going from the base down here to the vertex, and then you will also need to know your radius, and that's going to help us. Vertex is still this point right here, the pointy end, and then a right cone is like a cone that is not oblique. So I told y'all like oblique cylinders. A right cone is just like a cone that looks like this. All right, it's going to make a right angle from the vertex along this altitude, aka the height, not the slant height. So if we want to see a picture, you get a right angle there. And then slant height is this. The lateral area for a cone is just like the lateral area for a pyramid, except since the base is a circle, the perimeter is no longer called perimeter. It would be 2 pi r, aka the circumference, times the slant height. Now, if you simplified that, 1/2 times 2 is just 1. So you could just write pi times r times L. And then the surface area, that would be everything. Like, I imagine surface area is, if I wanted to cover this perfectly with, say, Christmas wrapping paper, how much wrapping paper would I need to cover the entire surface on the outside of this cone? That's what surface area is. Lateral area is like, how much Christmas wrapping paper would I need to cover it if I didn't want to cover the base too on the outside? So what you have to do is take your lateral area and add on the area of the base. In this case, a circle, so pi r squared. And since we have all those formulas, these 4 formulas, we are ready to do our 2 examples today. So on example 1, it says find the lateral area of each pyramid to the nearest whole number. I'm actually going to add in surface area too, because I want you guys to be able to do both on your assignment. This is kind of odd, but it gives us the altitude or height of 6, but we don't have the slant height. And if you remember, we just said the lateral area is 1/2 times the perimeter times the slant height. We need the slant height. Right now we just have the normal regular altitude height. The perimeter is going to be fairly easy because every side is 12 here for our square as the base. So 12, 12, 12, 12 gives us 48 for the perimeter. And then the slant height, what I would do is draw this right triangle. And if we want to draw it a little bit bigger so you can see it better, right now we know that the altitude or the height is 6. It's got a little arrow pointing to it. And the base, if all the way across here is 12, halfway, so just the base of this triangle, would also be 6. And then you'll have to find, let's call it L because it is the slant height. You'll have to find this L value by doing Pythagorean theorem. It'd be 6 squared plus 6 squared is equal to L squared. And then if you simplified, 36 plus 36 gives me 72. Good news is we're rounding on this one because it says round to the nearest whole number. So if we take the square root, that gives us 72, square root 72. I got 8.5 as my slant height. So 8.5 here. Now you can type all that into the calculator at once. 1/2 times 48 times 8.5. And that gives me 204 meters squared for my lateral area. But I said I want you guys to do surface area as well. So surface area just means you take the lateral area, 1/2 PL, and you add on the area of the base. Well, we already found this, it was 204. And the area of the base would be, this is a square, so you do 12 times 12, length times width. That gives us 144 for the area of the base. Add those together, and that gives us 348 meters squared. I'm also going to do part B with you guys, but we'll kind of skip C because it's the same as A, not the same answer. The answer for the lateral area is 51 meters squared. But we'll do part B here. So the lateral area is 1/2 times P times L. The perimeter is going to be pretty easy because this is a regular hexagon as your base. So if one side is 10, all the sides are 10, and there's 6 sides, 10, 20, 30, 40, 50, 60 as our perimeter. And then the slant height, we again don't know it. All we have is this right triangle here, and it says on your right triangle, we have, Let's put it up here. On your right triangle, we have a base of 5 root 3 and an altitude or height of 8. We need to find the slant height L. So again, we'll have to do Pythagorean theorem. 8 squared plus parentheses 5 root 3 squared is equal to L squared. And if we put it in the calculator, we can round. 8 squared plus 5 root 3 in parentheses squared gives us 139, and then we have to take the square root and gives us 11.8 as our slant height. So we're going to multiply all these. 1/2 times 60 times 11.8. And that gives us 354 approximately, if we're rounding. 354 centimeters squared for the lateral area. I also want you guys to be able to do surface area. And that would be 1/2 PL plus the area of the base. Now this base is a regular hexagon, so we can use our 1/2 AP. This would be 1/2 PL. And the area of a regular polygon is 1/2 AP, where A is your apothem or height, your altitude, and then P is still your perimeter. So if we substitute in, we already found 1/2 PL, it's 354, and then 1/2 AP. So 1/2, our apothem here is, it makes a right angle. It's this distance from the center to any side, as long as it makes a right angle with the side. That would be 5 root 3. And then the perimeter was 60. And since we're rounding, we can plug all that into the calculator. 354 plus 1/2 times 5 root 3 times 60, and that gives us 614 if we round up centimeters squared. 614 centimeters squared. Lucky for you, example 2 should be a little bit quicker. We'll just do part A. Part A, same formula, kind of. We're wanting to do lateral area, but I'll do surface area too. 1/2, instead of perimeter, it's the circumference, so 2 pi r, and then your slant height. And if we simplified this formula a little bit, we said those would kind of cancel out or divide out, and we're just going to have to substitute in these values. So pi is still pi. Our radius, we have a diameter of 26, but the radius is 13, half of that. And then your slant height, we don't have. All we have is this regular altitude, this distance of 22, and we have the base of this right triangle, which is 13. So if we were to draw that a little bit larger, we got 13, we got 22. We have to do Pythagorean theorem one more time and find this slant height. So it would be 13 squared plus 22 squared is equal to L squared. 13 squared plus 22 squared gives me 653, and we have to take the square root to get rid of the squared. That gives me a slant height of 25.6. And then you can stick that into the calculator since we're rounding to the nearest whole number. Pi times 13 times 25.6, giving me 1046 as my final answer for the lateral area. And that is inches squared. The surface area, you just take the lateral area and you add on the area of the base. That lateral area was pi RL, and the area of the base, in this case it's a circle, so we'll just say pi r squared. And then to finish up, pi, oh, we already found this, right? It was 1046. So let's not waste the time of plugging it back in. And then pi r squared would be pi times 13 squared. So we substitute that into our calculator. Our answer may be off a little bit because we rounded during the problem. But that gives me a final answer of 1,577 inches squared.